What is up, the people? What do you say we have ourselves a good old-fashioned teardown? I found this thing at a local store called Grocery Outlet, where they usually sell like I don't know if it's like closeouts or like things that are like overstock or whatever, but they seem to like get like these lots of things, and then they'll sell them for pretty cheap. I found this thing there. I thought it'd be pretty interesting to look at inside. It's a bug zapper solar light night beam. So it's got a white little strip here of LEDs, and then on the inside it's supposed to have a bug zapper. And if we kind of tilt it there, we can kind of see that there's these what I'm guessing are going to be like UV LEDs. So it's supposed to have a motion detector. This here I thought was some other sort of a sensor, but I guess that's the actually like the switch to turn it on and stuff. I see inside of there. They make it look kind of like one of those bug lamps. Let's see what sorts of stuff are to be found inside of this. And after I get it open here, take a look at what it says here on the back, because otherwise we have a lot of glare. So just going to cut around the perimeter. That's probably good enough right there. We can get the device out. So that's that. Oh, it actually has a little battery compartment in the back. Oh, there you go. It's like an 18650. I thought there was going to be like a couple double A's or something in there. And then there's a strip of double-sided tape here that's protected by that sheet. You're supposed to be able to like stick this wherever you want, or you can screw it down. There is some hardware included in there. So let's get this sheet out of here. So it comes with the anchors and some screws. All right, so let's see what kind of stuff it says here. Nothing all that crazy on here, at least nothing funny either. But the only questionable things I see here are this weatherproof IP54 rated. It's, nah, I think that's kind of questionable. And then it just has the instructions, or basic instructions, that the first press activates the light, and that's motion and light sensor. The second press to turn on the bug zapper, and then the third press activates both modes. Fourth press to turn off. And, well, nothing else really down here other than a few warnings. Do not touch the bug zapper while in use. Danger of shock. This is not a toy. Keep away from small children. I guess you can give it to larger children. That's fine. And body parts. Ah, man, they're always ruining my plans. All right, the interesting stuff. Instructions. We don't need instructions. All right, so there's 4 screws in the back. Looks like that's going to allow this back cover to come off. And let's let's see what happens if we stick something in there. Let's see if we hear a spark or something. So to activate the bug zapper, it's 2 presses. All right, that's on. I'm going to be using an insulated screwdriver. So here we go. Let's see what happens when this gets in there. Nothing. Let's see if I get closer to those bars. Nah, not even a spark. Okay, so I had to bridge between 2 of those bars before it did anything like that. So not very powerful. I guess if a bug did get caught in between the two, then that would do something. But I was thinking that maybe it'd be more capable of having a spark like jump the gap, because they're like really far in there, so bugs have to get like all the way up against the thing to even have anything happen. And those are not UV LEDs, they're just blue. And there's a slot down here, so I guess if any bugs do fry, they can just fall right out. Let's see if the motion detector does something. I will turn it on for motion and light sensor mode. Okay, that's on. Let's see if it turns off. There it goes, it turned off. I'm going to move and see if I'm going to wave my hand here and see if it comes on. So here I go. Oh, I guess I should probably turn off the light, huh? It's probably not going to trigger it if the garage lights are on. So let me go turn those off. All right, garage lights are on, but I moved, so I think that caused it to turn on. I'm just going to stay still for a bit. All right, it turned back off. I'm going to raise my hand, and hopefully the motion sensor will trigger it. Here we go. Hands moving. There, you saw me shadow. Yep. So motion sensor seems to work. And it seems to have an on time of about 15 seconds per event. So yeah, after about 15 seconds, it turns back off. All right, so I make sure it's off now, and let's go ahead and open it up. First of all, let's go ahead and remove the battery, just so don't risk getting a little zap there. And then I'm going to short out these bars just to make sure that there's no charge on a capacitor or something there. And heard a little spark there, so there definitely was a charge on that. All right, let's get a small screwdriver, remove these 4 screws, see what all we got going on in there. All right, there's all 4 screws loosened up. This should just pop open, it looks like. It's gone. And we have 2 wires, one for the positive, one for the negative, going to that board. See, there's a little, what looks like a little microcontroller down there. There's some diodes and stuff there. That's going to be like the, that's for the bug zapper portion. There's a strip with the blue LEDs. And looks like there's 4 screws holding that board down. So let's go ahead and remove those. There we go. So on the other side of that, we got our button there, motion sensor, a little transformer for the step up, and then a capacitor here to store the charge. But all these wires are kind of hindering it. It cannot come out. So I'm just going to undo a bunch of these wires. I'm just going to desolder them in case I need to do some sort of testing here in a bit. Okay, so that's the board, freed from everything else. That's the other side. Looks like there's supposed to be a capacitor there that this one doesn't have. Got some routing there for the high voltage isolation. We'll take a closer look at this in a bit here, but we'll set that aside for now. Nothing else going on in there except there's this sort of a, oh, this is for the bug zapper part to kind of separate the LEDs from the bars. And this little cap is for the motion sensor. So that's a lens that covers it just like that. And then the bars for the bug zapper are just these little plates here that have been, looks like they've been stamped, cut out, so that they just have like these fingers that just sort of like intertwine like that. So 2 contacts, one on each side. And those, that's a screw, so they've soldered the wires onto the screws directly. And this here is just a strip with the blue LEDs. So nothing crazy going on there. And the only things that are left are the white strip of LEDs in the front and the solar panel up there. So that capacitor there, that's a 650 volt capacitor, and a very simple circuit. Looks like that transistor there is going to be the driver for that transformer. So then we just have 2 wires coming out of here. Those are going to be for power. So this microcontroller here is probably going to maybe this transistor there. I haven't quite traced it out yet, but somehow it's going to be able to turn this on and off. And then we got a little 5-pin SOT235 chip right here. That's probably going to be a charge controller for the battery. And then we got a couple other transistors here. So these are probably going to be for like, I'm guessing one of these is going to be for turning on and off the high voltage circuit. One of them is probably going to be for the white LEDs. And another one's probably going to be for the blue LEDs, although I don't know which one's which just yet. From the solar panel comes into here. We see it goes to a diode. So this is simple enough. We can reverse engineer it and come up with a schematic. And since there's really nothing else to look at here, why don't we go take a look at that now? And here it is, the schematic. I know it looks a little chaotic and maybe a little crammed, but I was trying to fit everything into like a small area so that I could blow it up as much as I could. And also, I think another thing that makes it look kind of crammed is I have all these component designators like everywhere. They're not really necessary for the purposes of showing how this works, and it's something that I've been kind of thinking about as I make some of these schematics. But it helps me while I'm working on the schematic to be able to identify the components on the board, and so that I get them in the correct position and all that, so I don't make too many mistakes. All right, so the way this thing works is we've got our solar cell right here, and we've got our battery right there. The solar cell provides power to the circuit through a diode here, which is an M7 mark diode. And from what I found, it looks like these diodes are the equivalent of an 1N4007. And we see that there's also a line here tapped off of the positive of the solar cell to a 1K resistor that goes to a transistor. On the board, that diode is this diode right here and this transistor right there. R17 is that little resistor right there. So what this is doing is when the solar cell is providing power or producing power from a light source, some of that it's going to go through that resistor and go to the base of that transistor, which is going to allow it to conduct between ground and pin 5 of the microcontroller. And so what this would be doing is the microcontroller would actually be receiving power through that diode, through this 100 ohm resistor, which also powers the motion sensor. And then we see that pin 1 is the voltage input for the microcontroller. Now, unfortunately, I could not find this microcontroller anywhere. It doesn't have any markings on top, but if we flip it over on the bottom, it does say H2219XB17, but that number brought up nothing online, so no clue what it actually is. But the only things I can say is that it appears that pin number 1 is it's like its VDD line for positive, and 8 would be ground, and then it's got like 6 I/O lines. So getting back to the this transistor here, as long as the solar cell is producing power, it can ground out this line, and so that way the microcontroller knows that there is light present at the solar cell, whether it's sunlight or some other light source. The battery, it gets its it's connected to positive through that same line after the diode, so the battery can't like backfeed through the solar cell somehow, and that goes connected directly to U3, which is that SOT23 PHY device that was right there, which I've removed. As you can see, I removed the microcontroller and the charge controller. That way I could see, which traces went to what. But it's a BRCL3130ME, and it's very simple to connect. The 4 and the 5 just go to ground. Pin number 2 goes to the negative of the battery, and then pin number 3 goes to a 100 ohm resistor to the positive. So what it looks like this chip does is it switches a line to either like monitor charging for the battery, or it connects the other line so that it connects directly to, ground of whatever you're powering with it. But 4 and 5 are actually the same connection. I do have the data sheet for that. It's right here. So BRCL3130ME, and then it just kind of gives you a brief description of it and some of the functionality. And here's the basic circuit that you need for it. So a 1 microfarad capacitor between VDD and ground. And then 5 and 4, as you can see, are VM, and that goes to the negative of the circuit. The positive comes up here, and then we've got our battery right there. And there's that 100 resistor that we saw that connects between the positive and pin number 3. So very simple to implement into a device. So that's that. That's how the battery and the solar cell provide power to the circuit. We can see that the motion sensor is also powered through that 100 ohm resistor. And something interesting about this motion sensor is that some other ones I've seen usually require having like an external amplifier because the signal coming out is usually like analog. But this one here, I also found the datasheet for, and it says it's a digital pyroelectric infrared sensor. What caught my attention was that it says that it's a type of PIR sensor which integrates a digital control circuit and a human detection sensor. The human body detection sensor couples the sensed human movement signal to the digital intelligent integrated circuit chip through a very high impedance differential input circuit, and the digital intelligent integrated circuit converts the signal into an ADC digital signal, and all signal processing is done on the chip. I guess they're doing some sort of processing in here to detect human motion. So maybe it's like rejects like animal movement or something. No idea, but it sounds like it's got a lot more than most traditional PIR sensors that I had seen in the past. And also, as I mentioned, the output here is basically a digital output. It's not an analog signal. And because of that, it can connect directly to one of the pins on the microcontroller. But as we see here, pin 1 goes to positive, pin 2 goes to the microcontroller, but pin 3 also goes to the microcontroller. If we go back to the data sheet for the sensor, we see that pin 1 is VDD, pin 2 is REL, which is the signal output, pin 3 is VSS, which would be ground. So why would they have ground connected directly to the microcontroller? Well, I'm pretty sure that's so that during the day, when the solar panels are receiving power, or if there's like a bright light source, then internally the microcontroller turns pin number 4 high, so that effectively deactivates the motion sensor, so it's not sucking any power out of the battery or just using any power in general. And then once it turns dark and the solar panel is no longer producing power, the transistor turns off, which no longer pulls line 5 low, and so it must have an internal pull up. Once it sees that there's no low on pin 5, then the microcontroller can assume that it's nighttime or it's dark, and it can pull pin 4 low, so that way the sensor is basically getting grounded through there, and now it's able to operate and produce an output signal. So I thought that was kind of a clever way of doing that. Instead of having some other external controlled transistor, it just uses the microcontroller itself to turn the sensor on and off. Now at pin number 6, that's where we have the little button that was found in the front of the device. And that button, basically all it does is it connects ground to pin number 6, and that's how you change your mode. And then so lamp 1 or L1 right here, that's actually the string of LEDs. That's the white section that's in the front. I only put one LED here because they are actually all connected in parallel. It's a total of like 5 LEDs. And the way the microcontroller controls that is through pin number 7. It goes to the gate of what I believe is an SI302 N-channel MOSFET. So when the microcontroller is going to turn these LEDs on because it sensed motion, it just pulls this line high, which allows ground to be connected to the string of LEDs through a 1 ohm resistor. And then to turn the white LEDs off, then it just turns that light low, or it releases it and just makes it floating or something, because this 10K resistor here will also pull the gate down to ground and effectively turning this off and turning off the white LEDs. And then the only section left is the high voltage section for the bug zapper, and that's controlled through this P-channel MOSFET, which I believe is an HM2301B, and that is controlled by pin number 2 of the microcontroller. It goes through a 1K resistor, which is used to control the gate of that MOSFET. The 10K resistor here just pulls it high, so if this is not getting pulled down to ground, then the MOSFET can't operate. But that switches power over to what's marked L2, which is the string of blue LEDs, and those are connected in series with a 20 ohm through a 20 ohm resistor to ground. But this line also powers the high voltage section through another one of these M7 diodes. And that makes sense because if the bug zapper section is going to be on, you're going to want the LEDs to be on too. There'd be no point in powering this if the LEDs are not producing any light to attract bugs. Now, the oscillator section is what I believe is, I'm not up to snuff on my little transformer oscillators here, but I think this is what's called a block oscillator. And so what happens here is we've got a positive connected at all times, well, as long as the MOSFET is on at all times, to one of the pins of the transformer. They also applied that the positive to a pin on the transformer that's on the opposite side of it. And so that goes to another winding that's used to control the base of this transistor. In other circuits that I've seen for this type of oscillator, usually you'll have one connected to the positive voltage source, and then one of these windings would be connected to ground, and then the other side is the one that goes connected to the transistor. But in this one, looks like they did it the other way and just connected both windings to the positive, and then they have the other side of one of the windings controlling the transistor. So what that's going to do is when this portion of the circuit receives power, it's going to provide a positive signal here to the winding, but the other side can't go to ground because this transistor wouldn't be on yet. But as voltage flows through this 4.7K resistor, it'll go to the base of the transistor, which is going to allow it to conduct to ground, thus grounding the opposite side of the winding, and that's going to cause a magnetic field to start building up on the transformer core, which is then going to induce a current on the second winding. And the way that it's wired, it appears that what it would do is it would pull this line negative, because we already have a positive on this side. So if this gets pulled negative, it's going to be capacitively coupled to this capacitor, which is going to briefly pull this base down to ground or low, and it's going to turn off the transistor. which is going to allow the magnetic field that's on the core to collapse and reverse the magnetic field on that secondary winding, which is going to cause it to swing the opposite way. And now this side is going to become positive, which is going to allow the transistor to turn on once again and pull the winding of the transformer back down to ground, and causing the cycle to, repeat over and over again. So we get an oscillating magnetic field, which is going to be induced into this secondary high voltage winding. And what they've got going on this side is looks like it's just a voltage doubler. So if we assume, for example, that there's a positive on this 2 output here, and by the way, these numbers don't necessarily correspond to what's on the transformer. It's just what the model here in KiCad had already, and I just sort of wired them in a way that sort of made sense to what was on the board. But anyway, yeah, let's assume that we have a positive going on here on this pin, and the other pin here would be negative. So what that's going to do is it's going to allow this capacitor to charge, because this side is negative. Positive is going to flow through this diode. It's going to cause this side to be positive. And if we assume that the voltage coming out of here is say 200 volts. So now we've got about 200 volts charge on this capacitor, but there's nothing going to be going on here with this capacitor here yet, because this side is positive and this side would basically technically be positive also. And we store the charge into this capacitor. Once the magnetic field changes polarity, and now this side becomes negative and this side becomes positive, now we're going to have the negative being blocked by this diode. We can't short out the capacitor, but we are going to get a negative on this side of this capacitor. And since this side is positive and this had a 200 volt charge already on it, now we're going to get 200 plus 200, which is going to cause there to be 400 here. And that's going to be allowed to flow through this diode to the opposite side of this capacitor. So now we're going to have a 400 volt charge on this capacitor. And when the magnetic field once again reverses, then it's going to charge this one up again to 200 volts. And this is going to stay at 400. It reverses polarity. Then we're going to get another 400 pumping through here. So that's going to keep a steady charge on this capacitor. And then we have those metallic plates with the where the bug zapper portion is. And I just drew those as wires, kind of like fingers intertwined. These 2 resistors right here, those are just going to be for bleeding off the charge from the capacitor when the unit is not working, so that it doesn't store charge. And I mean, yeah, that's about it. Really basic. It just looks kind of complicated. To finish off this video, I thought I'd just talk a little bit about a bit of testing and some observations I made about these things. Now, as you can see, this one here is still in the package. And that's because I actually ended up buying 2 more of these, and turns out I paid $10 a piece for all of these. They were $9.99 each. But the first observation I made is I decided to test the solar panel on the first one that I took apart, and it puts out an open circuit voltage of about 6.6 volts, and that's in full bright sunlight, and then a short circuit current of about 70 milliamps. So the claims that are on the back of the package where it says a 5 volt 0.3 watt solar panel, it seems accurate enough. Also, I pried the solar panel off of the casing, and as you can see, the adhesive here is pretty crappy. It's not exactly adhered very well. And I think they've actually sort of made these channels here on the plastic, it's molded in there, maybe to better seal the panel here against getting water ingress through there or something. But there's a big gap right there. It was really only adhered in those areas. And so water could easily just kind of, go in there and drip inside of the device, which isn't good. But from the get-go, this one, the terminal there is already kind of rusty looking, and there's a tiny little bit of rust on that side as well. So sitting outside in the weather, even with just a bit of moisture, I don't think these things would last very long. I set this one up on a post of a pergola we have in our backyard, and I didn't want to screw it in or anything, so I just used a bungee cord to just kind of hold it in place there. And I thought I would just do that to test out the actual, the bug zapper portion of it. The motion sensor light activation thing, I mean, that seems to work totally fine. But what I found out about the bug zapper portion is that it'll still work during the day. If you have that mode set, the bug zapper, the LEDs inside, they just stay on. So the only way those turn off is if you manually turn it off with the button, or if the battery dies. And as you can see here, I put a little baggie there to just catch any bugs that might actually go into the thing, and we did get a few bugs. We don't have like a ton of bugs in the backyard at all times or anything like that, or at night. But if we kind of zoom in here into the little fingers there, you can kind of see that there's a few more. So as far as the bug zapper portion of this thing goes, it does work. I can't say that it doesn't, but I guess it would be kind of cool if it would stop using the battery to power it during the day. And also if the last mode that you set with the button would automatically be enabled at night. But it appears that once the battery dies, the unit just completely in an off state again. So you have to manually go and turn it back on like every time you want to use it. So I let this sit out there for a few days, and every night I had to go out there and like turn it back on to get the bug zapper to operate. I didn't bother with the motion detector portion because, as we saw, that appears to work fine. And once again, referring to the weatherproofing portion of this thing, this panel here is already like pretty loose. And I was actually, when I had it out there in the sun, I think the adhesive was so soft that like was able to like wiggle this, and I can still kind of wiggle it quite a bit. But this feels like it's already coming off. So let's see how much adhesive is actually on this portion, or this particular one. See? Yeah, they're not very well adhered, so it's easy for water or something to get in there. So if you were to like use one of these things, you'd probably want it somewhere where it could still get sunlight, but not have any form of like rain or some sort of moisture being able to like drip on it or anything, because it's quickly gonna like ruin it. And even as is, I doubt that this would last for like more than a few weeks. Alrighty, so that's gonna do it for this one. Thanks guys for watching once again, and we'll see you guys around the bench.